Greetings and welcome. Today we're talking about writing equations of parabolas. So we've seen standard form. I think we've also seen general form, which can take of two types, I guess. So general form of a parabola looks like this. It's either ax squared, or well, I guess you could divide it out. X squared plus dx plus ey plus f equals 0, or you could have y squared plus dx plus ey plus f equals 0. So the one with the x squared is your vertically oriented version, and the one with the y squared is your horizontally oriented version. And de and f happen to be your coefficients. So let's do a problem where we start with standard form and then have to write it into, start with general form and then have to write it into standard form. So let's say I've got the following. X squared minus 8x minus y plus 18 equals 0. So when looking at this, I see that I've got an x squared term, all right, and that's one of the unique things about parabolas compared to the other conic sections, is that there's only a single squared term in both. So the fact that it's an x squared tells me that this is a vertically oriented parabola. It also tells me that it must end up being of the form x minus h squared equals 4p times y minus k. So that's where I'm hoping to get this by the time I'm done. So in order to do that, I'm in fact going to move the y and the constant to the other side, and I'll have x squared minus 8x blank equals y minus 18 blank. Now, if there was a coefficient in front of this x squared term, I could actually factor it out first, and I would have to do that prior to completing the square. So, so let's complete the square. So negative 8 divided by 2 all squared is how I find my new c term. You take your b, your linear coefficient, divide by 2 and square it. So that's negative 4 squared equals 16. So I'm going to add 16 on the left-hand side. In the world of parentheses, it's still adding 16. So in order to balance that out, I have to also add 16 on the right-hand side. And now the left-hand side is a perfect square trinomial, so I can fast factor this. That's going to be x minus 4 all squared. Right, so you guys are all familiar with the pattern, square of a binomial. That minus 4 you can actually shortcut, take right from there, and of course it's just a plain old x in the front. Equals, and this is y minus 2 when I combine the 16 and the negative 18. Now, if y happened to have a coefficient out front, I would actually have to factor it out of both of those because the leading coefficient for my binomial here has to be linear, right? Notice it's a 1y right here all the time. So whatever you'd have to factor it out. So in this case, it appears as though it already was, or it's just a 1 here. So this would be my standard form. So let's gather the information from this. So I already knew that it was vertically oriented. I know that by looking at this coefficient, 4p is equal to that number. So therefore, solving for p, I would get p equals 1/4. Let's see, let's do that in the yellow, why not? So I would divide both sides by 4, and p is equal to 1/4. The fact that this is positive and it's vertical tells me it opens up, right? It opens towards the positive y-axis. So let's see, so our vertex is going to be 4, 2. It's the opposite of this number, right, is the x-coordinate. The opposite of this number is the y-coordinate. My focus is going to be, well, it's vertical, so I'm going to add p to the y-coordinate, y for vertical, right? So I would have 4, 2 plus 1/4, right? Which simplifies to 4, 2.25, I guess, if we leave that as a decimal. Or I could have that as 9/4. The axis of symmetry is in line with the orientation of the parabola, so since that's vertical, so is this, so that's x equals a number, and will equal the x coordinate, because this is x equals, right? And the directrix is going to be y equals, let's see what number here, well, it would be 2, your y coordinate, minus the value of p, so 2 minus a quarter. So that's going to give me the equation y equals 1.75. So those are the directrix and the axis of symmetry, the focus and the vertex. So everything that I kind of would need to know about this parabola, I was able to gather from that. Let's see, let me just do one more quick one of that type, and then we'll do one where we're writing an equation based off of some clues. Let's see if I can find a good one. So how about this? What if I've got 3x squared minus 30y minus 18x plus 87 equals 0. So let's see, I see the x's squared, so that means I'm going vertical here, right? That's what we're aiming for. So I'm going to move all of the y's and the constant to the other side. All right, and I'll have 3x squared minus 18x equals 30y minus 87. So this is a case like I was describing earlier where my leading coefficient is 3, so I actually have to factor that 3 out there. And I'm not going to do that with the y just yet because I'm still going to add something over here first, likely. So I don't want to factor that side just yet. So 3 times x squared minus 6x blank equals 30y minus 87 blank. Sorry. And so now we can complete the square on the inside of the parentheses here. So negative 6 over 2 all squared equals negative 3 squared equals 9. So I'm adding 9 in the world of parentheses is really adding, let's see, 3 times 9 is 27, right? So I have to add 27 to the other side as well. So let's fast factor this. So this is going to be x minus 3 all squared equals 30y minus, let's see, so that's subtract the 7, or add the 7 part, that's going to be negative 80 minus, or add 20, so what, negative 60. And now what I can do is, now I'll factor out this coefficient of 30. All right, so I'm not factoring out the greatest common factor, I'm specifically aiming for just whatever that coefficient is. And I do that in both cases, right? Because otherwise I could have taken an x out of up there as well. So that's 3 times x minus 3 squared equals 30 times y minus 2. And I'm almost there, but I don't want this 3 here, so I'm going to divide both sides by 3. And I'll have x minus 3 squared equals 10 times y minus 2. And so here's standard form, and then I could gather all of my pertinent information from it. Vertex is 3, 2. The value of p is 10/4 or 5/2 or 2.5, right? This is vertically oriented. P was positive. It's opening up. So I would add 2.5 to the vertex to get the focus. I'd subtract 2.5 from the y coordinate to get the directrix and go from there. So one last example. Let's do one where we have clues. Clues. Here we go. So let's say I've got, here we go. The parabola passes through a point, all right, the point, let's say 2, -1. All right, so that's not the vertex, that's not the focus. That's just a point that happens to be on the parabola and has vertex at -7, 5. The parabola also opens to the right. Let's see. So based off of these clues, well, let's see. It opens to the right, so that means it's horizontally oriented. So I'm going to be looking for a y minus k squared equals 4p times x minus h. Right? That's what I'm looking for. That's the version of standard form that I'd choose. What other facts do I know? I know that the vertex is at negative 7, 5. I know this fact is the trickier one. That is just some particular x comma y combination is to negative 1. All right, so that means if I plug that in for y and x, this equation would be true. All right, it's a point on the graph. I also knew that it opens to the right, which tells me that p will be positive, but I don't think I'll need that just yet. But let's plug in this for h, this for k, this for x, this for y. That takes up 4 of my 5 variables, leaving 1 unknown. That's something I know I can solve for. So let's plug in what we know, solve for what we don't. Classic algebra right here coming at you. So negative 1 minus 5 squared equals 4p, still unknown to us, but that's fine, times 2 minus negative 7 or plus 7. So let's simplify this. So this is negative 6 squared equals 4p times 9. So that's, no, I almost said negative there. Positive 36 equals 4 times 9 also happens to be 36p there. So to solve for p, I could divide both sides by 36. And I would get p is equal to 1. Right? So now I can write the equation using the vertex and the value of p. So let's just plug in what we got. So I'll have y minus 5 squared equals 4 times 1 is just 4, x plus 7. Right, so here's the equation, and then you could gather everything you want to know from that. So hopefully that explained everything you need to know, and I'll talk to you guys next time. Bye-bye.